Welcome to The Explainer. Today, we're going to dive into a topic that's right at the heart of the whole AI revolution: how to make those super powerful GPUs work seamlessly with Kubernetes. So, this is the big question, right? Kubernetes is an absolute master at managing your standard compute. But getting it to orchestrate specialized, high performance hardware like GPUs, well, that requires a totally different approach. It's a puzzle a ton of developers are facing, whether you're in a massive cloud environment or just tinkering around in a home lab. Okay, so let's get into it by starting small, with what you might call a home lab setup. Before we can even think about automating anything, you have to understand the fundamentals. Think of it like a basic recipe with three absolutely essential layers that have to work together perfectly. To get a GPU working inside a container that's being orchestrated by Kubernetes, these three layers have to communicate flawlessly. You've got to correctly configure the host operating system, then the container runtime that actually runs your apps, and finally, Kubernetes itself. If you get just one of those wrong, the whole thing just doesn't work. First up, layer one, the host machine itself. It all begins with the vendor's device driver. That's the software that talks directly to the hardware. Now, the really crucial part here, the thing that trips everybody up, is this dependency. The driver's version has to be compatible with the CUDA toolkit version that's baked inside your container image. It's this compatibility matrix you've got to get exactly right. Next, you need a bridge. That's where the container toolkit comes in. It's this special piece of software that kind of hooks into your container runtime, like Containerd or Docker. And right before a container starts up, this hook injects all the necessary info, the drivers, the libraries, that the container needs to actually see and use the GPU on the host. Without that bridge, the container is totally blind to all that powerful hardware sitting right outside of it. And finally, that brings us to the Kubernetes layer. Here, you install something called a device plugin. This is the component that basically taps the Kubernetes scheduler on the shoulder and says, hey, I've got a GPU available over here on this node. It advertises the GPU as a resource you can schedule, just like CPU or memory. Without it, Kubernetes has no idea the hardware even exists, and your pods can't ask for it. So that three-layer recipe we just went through, it works perfectly for one machine. But what happens when you move from that cozy little home lab to a real production cluster with hundreds, maybe even thousands of nodes? Well, that manual approach starts to fall apart, and that's where the real pain begins. Yeah, that manual approach just completely breaks down. You're not managing a single machine anymore. You're trying to wrangle an entire fleet. In this complexity, it's not just a small headache. It becomes a massive operational challenge that can bring whole projects to a grinding halt. All of a sudden, you're navigating a minefield of issues. You've got different GPU models that need different drivers. Your nodes slowly get out of sync. That's something called configuration drift. Upgrades become this super high-risk nightmare. And maybe worst of all, you often end up managing two completely separate software stacks, one for your CPU nodes and another for your GPU nodes. You're basically doubling your workload. So, to solve these exact scaling pains, the community turned to this really powerful cloud-native pattern, the operator. Honestly, the best way to think about it is as an automated expert for your cluster, like a robot administrator that handles all that tedious, error-prone work for you. At its core, an operator basically encodes the knowledge of a human administrator directly into software. It's constantly watching the state of your cluster, and it works automatically in this control loop to make sure the actual state of your nodes always matches the desired state that you've defined. And this just illustrates the difference perfectly. On the left, you've got that long, painful list of manual commands you'd have to run on every single machine. But on the right, you just declare what you want in a single file, you apply it once, and the GPU operator takes care of making it happen correctly on every single GPU node in your cluster. So the operator follows this consistent automated workflow for every node. First, it discovers which nodes have GPUs. Then, in the right order, it installs the Containerized driver, configures the toolkit, and deploys the device plugin and monitoring tools. And this part is so important. It validates that everything is working perfectly before it allows Kubernetes to schedule any of your AI workloads on that node. But this kind of automation, it does more than just make setup easier. It actually unlocks advanced capabilities that let you use your, let's face it, very expensive GPU hardware far more efficiently. I mean, you don't want a $1,000 piece of hardware just sitting there idle, right? And as experts in the field point out, once you have GPUs up and running, the real goal becomes efficient sharing. You want to squeeze the absolute maximum value out of every single card. The GPU operator lets you configure these really powerful sharing strategies just by declaring them. You can use something called MIG, or multi-instance GPU, to physically slice a single GPU into smaller, fully isolated instances. Or you could use MPS for concurrent processing. You can even use time slicing for things like development workloads that only need the GPU every now and then. And what this all boils down to is a massive simplification of your infrastructure. That's the core benefit. You no longer have to build and test and maintain separate OS images or different software stacks for your CPU and your GPU nodes. It all becomes one unified, manageable system. So that really brings us to the key takeaway. The whole journey of using GPUs in Kubernetes is the story of evolving from a complex manual process to a simple, declarative, and automated one that's actually built to scale. It's about telling the cluster what you want, not having to tell it how to do it step by step. Because once this automation is in place, it frees up developers, data